This is our first section of Unit 10. We're doing 10.1 covering area and perimeter. So before I jump into any examples, I'm going to go ahead and define some of these for us. So first off, let's talk about perimeter. Perimeter is the distance around the outside of a figure, okay, of a shape. Okay, so how long is the distance if you were to travel around the edge of the shape? Okay, it's one dimensional, it's just length, okay, just distance. Okay, to find that distance, okay, there's a few different things you can do. Some shapes, you can use a formula. Okay, so for instance, a rectangle, two of the sides are the same and the other two sides are the same. That's your length and width. So you can use this formula that says perimeter equals 2L plus 2W. Okay, so you can use that for perimeter of a rectangle. Okay, for a square, all four sides of a square are equal, so you can use the formula perimeter equals 4 times the side length, so 4S. For all other figures, okay, with the exception of a circle, all you have to do is add up all the sides. That's what perimeter is. Perimeter means add up all the sides. You can do that in rectangles and squares as well, but they also have these formulas for square and rectangle. Okay, but you can always just add up all the sides to get your perimeter. Okay, now it says with the exception of a circle, because a circle is not a polygon, it's round. Okay, there's a curve all the way around the edge. So it has a special term. It's called circumference. So circumference is the distance around the outside of a circle. Okay, so if I have a circle, okay, here's the center. It's this distance around the outside. So if I start here and I go all the way around to where I started, that's the circumference, the distance around the outside. Okay, it's like perimeter, it just has its own term, circumference. So circumference and perimeter are similar. It's around the outside, it's one dimensional. Okay, so now let's try some of these examples with perimeter and circumference. So in this first one, this says the length of a rectangle, I'm going to number this number 1. The length of a rectangle is 4 more than twice the width. The perimeter is 62. Find the length and width. Okay, so remember, in a rectangle, we've got 4 sides. The 2 across from each other are the same. So it says, we're going to come up with an equation to represent what it says right here. The length is 4 more than twice the width. So I'm going to write that out. The length is 4 more than 4 plus twice the width. So that's 2W. So the length is 4 plus 2W. So you could use the formula and replace length with that expression. So the formula says the perimeter is 2 times the length plus 2 times the width. And I'm going to come here to length and I'm going to plug in what we just said. So I'm going to replace that with 4 plus 2W. All the rest of it's going to stay the same. There's a 2 in front, there's a plus 2W at the end, and that's the perimeter. So now to simplify this, I'm going to distribute to get rid of my parentheses. So that becomes 8. 2 times 4 is 8. And 2 times 2W is 4W. And then you've still got the 2W on the outside. So now I'm going to simplify this, combine the W's. So that is 8 plus 6W equals the perimeter. Now, I'm going to come up here and I'm going to plug in for the perimeter because they said the perimeter up here is 62. So I'm going to plug in a 62 over here for the perimeter. Now, to solve this for W, I need to get the W alone. So I'm going to subtract 8 from both sides. So when I do that, I'll end up with 54 equals 6W. I'm running out of space, so I'm going to come up here. Okay, so I've got 54 equals 6W. How am I going to get rid of the 6 in front of that W? I'm going to divide because it's 6 times W. I'm going to divide the 6. What you do to one side, you do to the other. So now I've solved, and that's 9. So my width is 9. Now I can come back here to find the length. Okay, it says that the length, I'm coming back right here, it says the length is 4 plus 2 times, and then W is 9. The width is 9. Okay, the width we came up with was 9. So when I solve this, I end up with 4 plus 18. I get 22. So the length is 22 and the width is 9. Now you can come up here and you can confirm, okay, does that work in this rectangle? If I say the width is 9, that's going to be on both sides, and the length is 22, that's going to be on both sides. Do all 4 of those. If I add 22 plus 22 plus 9 plus 9, does that equal 62? And it does. Okay, it checks out and it does equal what they say the perimeter is of 62. Okay, so that was a multi-step problem. We had to use what was given to find one of the side measures, then use that side measure to find the other, and then we checked it to make sure we got the right perimeter. All right, now in this square in number 2, it tells us the perimeter of a square is 20. So again, the perimeter is 20. Okay, so in that formula, I'm going to replace the P with 20. And they ask for the length of the sides. That's S. Okay, what is the length of one of the sides? So I'm going to solve this by dividing out the 4. And I get that the side length is 5. Now, they didn't give us any units in these first 2 problems. So I don't know if that's inches or feet or meters or miles. I don't know. So I'm just going to leave it as 5. So the sides of the triangle are 5. And then you could confirm, you could check that. You could say, okay, if I have a square and all the side lengths are 5, do all of those added together equal 20? And the answer is yes. You add all the sides, you get 20. So far, so good? Now, if we have a different shape that we don't have a formula for, here it says we have an equilateral triangle in number 3. Equilateral is the key word here. That word equilateral means all sides equal. Oh, it says it right here. An equilateral triangle is a triangle that has 3 sides all the same length. Okay, all 3 sides are the same. Now it tells us the perimeter of this triangle is 34.5. So remember, perimeter is all 3 sides added up. But if all 3 sides are the same, side, 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 that's just 3s, isn't it? Of an equilateral triangle, it's just going to be, the perimeter is going to be 3 times the side length because all 3 are the same. So now I'm going to come up here and I'm going to plug in, the perimeter is 34.5. And I'm going to set that equal to 3s. And then to solve for the side length, I would divide by 3. So the sides of this triangle come out to be 11.5 when you divide that, 11.5. Now this time they did give us units, it said inches. So the sides are 11.5 inches. All right, let's try a circle. Okay, so we talked about circumference. It's the distance around the outside of the circle. But look at these formulas. So the C is the circumference. And then here you can have 2 pi r or pi d. Okay, remember this symbol pi. If you are using Desmos, you may use the pi symbol. However, that pi, you can't, there's not a pi button in our 4-function calculators. So when you're taking like the TSI or some test that doesn't give you a graphing calculator or a scientific calculator, you have to know the value of pi. So most of you know pi to be 3.14. We're going to take it a few more place values so that our answers are as accurate as possible. So I want you to use those 5 decimals, 3.14159. So 3.14159 is what you're going to use to calculate if you're asked for a decimal answer. Now I'm going to talk about 2 ways you can write answers dealing with circles. You can leave the pi symbol in them. If they say leave your answer in terms of pi, they want that pi symbol as part of the answer. Okay, so here I'm going to take the circumference, and it tells me this time the radius. Get a different color for that. Okay, so the radius, remember the radius is the distance from the center of the circle to the edge. That's radius, that's r. D, if you're told you have your D, that is diameter. Diameter is all the way across through the center. Okay, so diameter is all the way across. Radius is halfway across. Does everybody understand the difference? So this one gave us radius, so we are going to use the formula that has radius. So 2 pi, and then my radius is 6.8. Now, if I just multiply 2 times 6.8, if I only multiply the radius times 2, I leave the pi symbol there, I get 13.6 pi. I just multiplied those 2 together. This is your circumference. Now they did give us units, centimeters. This is the exact value. Okay, this is what they mean when they say in terms of pi. They mean you should have the pi symbol in your answer. Now, if they ask you to round your answer to a certain place value, you can type the 13.6 times 3.14159. And that would come out to 42.73 if we go to the hundredths. And that would also be centimeters. Okay, this is the rounded value. So exact versus rounded. Pay attention to what your question wants your answer in terms of. If they say round to the nearest tenth, hundredth, thousandth, okay, you're going to round your answer. Okay, if they say leave it in terms of pi or give an exact answer, you're going to leave that pi symbol there. All right, so that's it for perimeter and circumference. Let's look at area. So area, okay, area is, perimeter was the distance around the outside. Area is the space inside a figure. Okay, it is two-dimensional. Meaning your values, your units are squared. They have that power of 2 on them. It's two-dimensional, so your units will be squared. So square feet, square inches, whatever the units are. Okay, if we want to go back up here to where we talked about perimeter, we can add that it's one-dimensional. Okay, so perimeter is one-dimensional. Okay, so you just leave your units, no squared. Okay, so it'll just be however many units, so centimeters, inches, feet. Okay, but area is going to be your units squared. All right, for a rectangle, okay, a rectangle does have a special equation for area. Area of a rectangle is length times width. So instead of adding the two lengths and the two widths together, we are multiplying the length times the width. In this problem, this is number, I don't think I numbered that last one, it was 4. So this is example 5. Dr. Wright, a veterinarian, decides to fence in a large rectangular area in a yard behind her office for exercising dogs that are boarded overnight. Part of the yard to be fenced will be 40 feet long and has a perimeter of 126 feet. What will the fenced in area be? All right, so I'm going to draw a picture of a rectangle, and she says it is 40 feet long. Okay. Now she tells us the perimeter is 126. Well, remember, perimeter is 2 lengths plus 2 widths. So I'm going to need, that's L, is 40. I'm going to need to plug in my perimeter and my length to solve for the width so I can get area. So the perimeter is 126. The length is 40. and I don't know W. That's what I'm trying to solve for. So this becomes 126 equals 80 plus 2W. Then I need to move that 80 to the other side. So I end up with 126 minus 80, excuse me, which is 46. So we have 46 equals 2W. And then you have to get rid of the 2, the coefficient, by dividing. And what you do to one side, you do to the other. So this comes out that the width is 23. Now, I'll go over here and I'm going to label the width is 23. So now I can plug in for area and I can say, okay, the length is 40, the width is 23. I will multiply those together to get 920. So my area of this rectangular fenced space is 920. Now, all of the units were in feet. Those were the dimensions were measured in feet, but we multiplied them together. Feet times feet is feet squared, just like x times x is x squared. So this is in feet. The abbreviation for feet is just FT squared. So the area of this fenced yard is 920 square feet, or feet squared. All right, let's try one with a square. Since a square's length and width are the same, we can just call it S for side length, since all 4 sides are the same. And you just multiply it by itself, because it would be side times side, because it's the same. So you can think of that as side squared. Okay, so area of a square is the side length squared. So this tells us the area of a square table. Okay, so I'm going to sketch my square. The area is 225. That's the space in the middle. I want to know what's this side length around the outside. Okay, and so I'm going to plug in 225 for A, and I don't know S. Now to get rid of a square, just like we did this past unit, you should have done this on the test yesterday when we were doing Pythagorean theorem and we had A squared, B squared, and C squared. When we were trying to solve for one of those, we had to take the square root. The square root is the opposite operation for a square. So that gives me the side length by itself, and the square root of 225 is 15. Now we do know the units for the area were in inches squared, so just the side length will be one-dimensional, so it's just inches. So it's a square with 15-inch sides. All right, for a triangle, your formula for area of a triangle is 1/2 the base times the height. Now you can write that with 1/2 in front of B and H, or you can write it as B times H divided by 2. That's also taking half. Dividing by 2 or multiplying by half, those are the same thing. So whichever format you prefer. Now we do need to make sure that we understand that in a triangle, your base and height form a 90-degree angle. Okay, so your height and base here in a right triangle, if the triangle is not a right triangle, there's not a 90-degree angle in the triangle, the height has to be drawn in to be perpendicular with one of the sides. So then this would be the base, and that dotted line or dashed line would be the height. Okay, so just make sure you understand base and height have to meet at 90 degrees. They have to be perpendicular. So this one says a small sailboat has a triangular sail, the area of which is 30 square feet. Okay, so that's the area. The base is 5 feet. Determine the height. So we're going to work our equation backward. We're going to plug in 30 for the A. I like to do divided by 2 instead of the 1/2, but that's up to you. And then it tells us our base is 5 feet. So that goes in for the B. So 30 equals 5H over 2. So the first thing I'm going to do is get rid of the divided by 2 by multiplying both sides by 2. So then I end up with 60 equals 5H. Now I have to get rid of the coefficient of 5. So the opposite of multiplying by 5 is dividing. So then I have 12 equals H. So determine the height. That's what I just found. It's 12. Now the area was in square feet, so the height is just in feet. So 12 feet will be the height of that sail. Area of a trapezoid has a special formula as well for area. Again, you can do the 1/2 in the front like shown, or you can do all of this, base 1 plus base 2 times the height all over 2. You can write it that way, or you can write it with a 1/2 in front of the parentheses instead of doing it as a divided by 2. So the seats in an amphitheater are inside a trapezoidal area. The base of the trapezoidal area, the bases are 80 feet and 200 feet. So you need to remember what a trapezoid looks like. A trapezoid has 2 sides that are parallel, okay, and then they're connected, and these sides are not parallel, okay? So 2 parallel sides are the bases. So this would be base 1, this would be base 2. The height is the distance between those 2. And again, it's got to be perpendicular to the bases. The height and bases are perpendicular. They make a 90-degree angle. Okay, so in this example, it says the bases are 80 and 200, and the height is 100. Find the area of the floor occupied by the seats. So I want the area of this trapezoid. So base 1 is 80, base 2 is 200, the height is 100, and it's all over 2. That's in the formula. So you can calculate that all at once in Delta Math, or you can do order of operations to do this by hand or step by step in a 4-function calculator. So 280 times 100 over 2. So that would be 28,000 divided by 2, which would be 14,000. So 14,000 is the area. And again, all of these were measured in feet. So area is feet squared. This area is 2-dimensional. So your units must be squared. Okay, you found the average of the bases and multiplied by the height. That's what the trapezoidal area is. All right, last but not least, area of a circle. Okay, so a circle again uses pi. The R is still the radius. Okay, so if you need to sketch that again, you can write that again. A circle from the middle to the edge is the radius. And if you need a reminder, in place of pi, we're going to type 3.14159. Okay, those are the things we need to know to be able to answer this question. It says a cookie cake has a diameter of 12 inches. Remember, diameter was all the way across. Okay, your diameter of 12 inches, if I were to sketch this, this is my cookie cake, and they tell me all the way across is 12. What's halfway across going to be? What's half of 12? So the radius is 6. So the radius is 6 if the diameter is 12. Determine the area of the cookie. So area is pi, r is 6, and then it's squared, pi r squared. So if you want the exact answer, 6 squared, that means 6 times 6 is 36. And then we leave pi in the answer. And this was in inches, so area would be inches squared. That's the exact answer. Or you can plug it in, the 36 times 3.14159, and get 113.10 approximately inches squared. Okay, so this is in terms of pi. This is rounded. So pay attention to the wording on your practice. I think you have some of each where you may be asked to leave it in terms of pi. You may be asked, to round to the nearest 10th, 100th, 1000th, whatever it is. Okay, we feel okay about area and perimeter? All right, so your practice is in Delta Math. Okay, it's this one here that has today's date, says perimeter and area 10.1. You can see for each of the question types, I've only assigned you 2. So you need to get 2 correct in each of these sections to get 100. If you get one wrong, it does not hurt your score. You just have to try a new problem. You keep going, keep trying. It'll keep generating new problems until you get them correct. Okay? So you're doing 2 from each of those sections on perimeter and area.